So can you guys see my slides?
Yes.
Okay. Great. So let me first introduce myself. So my name is Shankar Karuppayah. I'm a senior lecturer from University of Science Malaysia, but currently I'm pursuing my postdoc attachment at Technical University of Darmstadt since July 2019. And my research interest is in the area of cybersecurity, malware, and distributed systems. So first, I would like to present a disclaimer. Parts of my presentation were inspired, contributed, or adopted from several other presentations in the past, as well as some research papers. And also, for those who have your laptops with you, if you can, please also start installing Wireshark if you don't have it yet to benefit from the hands-on session towards the end of my presentation today. The outline of my presentation is first I will introduce what is IoT and what is IoT botnets. And then we will look into a case study of one particular IoT botnet called Mirai. In specific, we will look into how Mirai operates, the different components within Mirai. And then we will look into some code aspects of how Mirai is developed, as well as play around with some network traffic or data sets of Mirai and try to understand what can we see from the attacks originating from Mirai. And finally, we will briefly discuss about how to defend against Mirai and conclude my talk. And for those who have not downloaded the resource kit that also includes my presentation slides, you can proceed to download it at bit.ly/DCNDS. Okay, so what are botnets? So botnets are actually, sorry, what are bots? What are bots? They are actually software agent or piece of code that is working for you. For example, you can have buyer agents retrieving information about goods and services, or also known as shopping bots. You have bots that are involved with stock markets. You have user agents or personal agents. Some of you have mobile phones like Android or Apple. You have Siri, you have Alexa for Google devices. You have Google web crawlers that crawls and tries to index all the different websites that are reachable towards the internet. You can create bots to automatically check your email, play computer games, find information for you, and so on. So these are the original definition of bots, but these are all good bots. So there are also a different category of bots that we can consider they're not so good. So for example, you have game bot. Imagine that you're playing a game with an opponent, someone else, your friend, but your friend could actually program a bot to play on behalf of him, which means so bots can think far ahead and they can do actually a lot of moves that are more advanced than what a regular user could do. So it's an unfair game, basically, if you implement it on a game. You also have bots that perform itself as automated scanners. So you decide to scan a lot of vulnerabilities, for example. But the most prominent, the most lethal aspect of bots is botnets. So a simple definition of botnet is a network of infected machines commanded by a bot master. So you have a person who's controlling malware infected machines over the internet. And why he does that? Pretty much he can do a lot of attacks. For example, DDoS, distributed denial of service attacks, information theft, Bitcoin mining. There are a lot of examples. So, but that's a basic definition of what are botnets. Then what is IoT or Internet of Things? Pretty much, there are a lot of definition of Internet of Things, but this is one definition that I really like. Internet of Things is any device belonging to anybody that can be anywhere, that could operate in any business over any network at any time. So this is a very simple example of how IoT devices could actually be classified. You can think of your smart bit, your Fitbit, sorry, Fitbit, smartwatch, your mobile phones. They are all part of Internet of Things. This could also include your refrigerator, your car that is having internet connectivity, and so on. So it's everything basically. So when we go into IoT botnets, what is it? before we go into IoT botnet, we just have to understand how regular botnets work. I gave you a definition that a botnet is a network of infected devices that are controlled by a bot master. So when a bot master needs to control the bots, he has to have something that we call a command and control server, or short CNC. So the image here on the left, you can actually see a CNC device that is being used to control all the infected bots. But when you go into the domain of IoT, nothing changes except that instead of PCs, you have your ovens, you have your webcams, you have your baby cams, your TV media players, all of those devices that are connected over the internet, which could start taking instructions from a CNC. That's about it. Now, moving forward, before we proceed, may I know how many of you have actually heard about Mirai in the past? Can I have a simple raise of hand? Okay. Did I? Okay. So we have a couple of you have seen or at least heard about Mirai. So let's go a bit more detail about what is Mirai. So basically, Mirai is an IoT botnet, which at some point was discovered to have around 50,000 unique IPs, which consist of Mirai infected devices. Now, Mirai primarily targeted CCTV cameras. So there are a lot of CCTV cameras that belongs to different vendors that have been exploited by Mirai. And these exploited devices were used as a platform to launch DDoS attacks. The command and control code is coded in Golang. It's a Go programming language, while the bots were coded in C. Essentially, and you can program it in any language that you want to, because it all communicates over the internet. Now, what's interesting about Mirai is that the source code for Mirai was leaked by someone called Anna Senpai over GitHub after some time. No, on a forum after some time. Ever since then, we have seen a lot of variants that derived their base code from Mirai's source code, basically. Now, at the point of infection, I told you there's about 50,000 IPs. And if you look at the heat map of how they were distributed, you can see infections up to 164 countries. And then if you see closer, I'm not sure how clear is the image on the screen out there, but those pink ones, let's say here, are the ones with the highest number of infection here, as well as some other places here. But primarily, it's targeted close to East Asia, Southeast Asia, and so on. So those were the countries that you had most number of infections. Now, the timeline of Mirai was interesting. So it was first discovered in 2016. So it was January 2016 when it was first detected, but it was laying dormant for quite some time, except infecting other machines, recruiting more machines into the botnet. And then around September 2016, an attack started. So an attack started on OVH. That's, if I'm not mistaken, it's one of the ISPs over there, followed by a big attack, which is close to 623 gigabits per second DDoS attack on Krebs on security. How many of you have heard or following Krebs on security? Have anyone? Okay, so we have some people. So interesting thing about Krebs is that he writes a lot of well-thought, well-researched articles on cyber crimes, especially discovering who's behind certain botnets, what are their modus operandi, and stuff like that. So the owners of Mirai have decided to launch an attack on Krebs after realizing that he has wrote something that discloses information about Mirai to the public. And that actually made his website down for 4 days, 4 continuous days. And after that, there was an attack on TEIN. TEIN is a DNS provider, which provides name resolution for clients like Amazon, GitHub, Netflix, PayPal, and Reddit. Now, what happened is that all these guys, I mean, regular users that are trying to access Amazon, GitHub, and these services were not able to connect to the services because the name servers were actually down during that period. And besides that, you also have the recorded attack on Lone Star or Liberia Lone Star, which is a telecom operator, which has most targeted victim by attack count. So these are some of the key milestones of Mirai from 2016 and 2017. And if you look into the geographic distribution of Mirai on the 21st September 2016, you could see that Mirai infections were quite a lot in Brazil, Colombia, Vietnam. So these are sorted based on the number of infections, basically. Well, this is just for information, but we don't actually have, I think we don't have any representatives or participants from these countries here. So this is just for your information. So the question is, how does Mirai work? So Mirai has a propagation vector, which is to perform internet-wide scans on ports 23 and 2323, which are exclusively for, well, most commonly used for telnet services. And after being able to scan and identify that, yeah, okay, there's a node online, it will try to brute force using default username and password. So if you have experience buying an IoT device, whatever device that you want, it could be a wireless router, wireless access point and stuff like that, they usually have a default username and password that is either written in the user manual or somehow known to the users. The assumption is the user would eventually change the default username after setting up whatever that is needed. But the question is, how many of us here, I mean, among you guys here, that actually do change your password after purchasing a new device? Do you really change your password from the default credentials to something else?
Yes.
Okay, good. But besides saying yes, I think there's a lot of regular people out there that are not worried, not bothered, or just didn't know the implication of not changing the default passwords. We actually did a small research in Malaysia, asking around what is the main reason that, or rather, the question was slightly different. When you buy a new device, what are the main things that you do? The first thing that they say is that I will first try to configure it to make it work. And after that, I just use it. Now, in the process of configuring it, usually you will go into IP configuration, whatever it is, but password changing usually happens or usually thought to take place at the end of the configuration. But at the point of something working, you will immediately start using it and then you forgot about changing your default username and password. That is one of the findings that we have received from the survey that we have done. Anyway, so upon propagation, Mirai will then perform the infection by loading a binary of itself into the memory and then patch other vulnerabilities that exist on the device itself, which means there are a lot of other vulnerabilities that are known for other type of botnets to exploit. So what Mirai does is that once it has access into a device, it makes sure that other other botnets will not be able to infect this particular device. So it's a bit of selfish way of doing it, but that's their modus operandi. And the most common attack that has been carried out using Mirai was DDoS attacks. So let's look at the architecture or the inner workings of Mirai. So how does it propagate? First, you have a scanner. You can consider the scanner as the very first infected, let's say, webcam. So this device will start scanning for nodes outside in the web that are reachable. And once it knows that a node is reachable, it will try to brute force using default username and password. Once it has identified, okay, this node X is reachable, and this is the username and password that can be used to access it, the scanner or the first device will send this information to another device, or we call it the loader, and it will inform the loader that, okay, this is the credentials that you can use. Now, this loader will use Go script to pass the credentials using a simple standard input pipe, and the loader will then connect to the IoT device using the username and password given earlier. Upon connecting, it will check if the IoT device has the capabilities or has the following packages installed: wget and tftp. So for those who are not aware of what is wget, it is pretty much a command line tool to download files or download any kind of things, basically. Now, if the wget or tftp tools are available, then the loader will download shell command, will download the binary of Mirai into the device. So the binary of Mirai is actually hosted on loader, and then there will be a script executed on the IoT device that tries to actually pull the binary file and then install on the IoT device. If in the step number 4, there were no wget tools or something like that, then the loader will have an additional step, which is to use a simple echo command to load a small binary that will then be able to download the real Mirai binary. And after that, Mirai binary will be downloaded and installed. Now we have the IoT device installed with the Mirai binary. After this, we can now participate in the attack, and we will just wait for a command and control server to send us commands on which victim should I actually launch a DDoS attack and so on. So that's pretty much how Mirai works. And for those who are interested, the source code of Mirai has been leaked and it's available on GitHub. So you can actually have a look at the source code on the link specified below here. Any questions so far?
Not yet.
Okay. Feel free to interrupt me with questions even during the presentations. I don't mind stopping and explaining during my presentation. Okay.
There is a question.
Yes.
Okay.
Hello. I see at the presentation before that there is a Mirai attack at Indonesia. Could you explain how we find out the Indonesian origin?
Sorry, if I get it correctly, you are claiming that there have been Mirai attacks or infections in Indonesia.
Yes.
How do I identify whether it's an Indonesian infected machine?
Yes.
Okay, so in the process of monitoring IoT device, in the process of monitoring botnets, what we do is that we speak the same protocols that infected machines would otherwise speak. For example, if the CNC can perform, can send some commands to the infected machine, the infected machine will reply accordingly. This is one aspect of it. Assuming we are able to have a tool that can fingerprint infected devices, which means we will be able to enumerate infected machines. I will know that this IP, this port has one Mirai infection. So what we do is that in the process of monitoring, we get the list of all infected machines. And then we have this, a lot of geo IP resolution database like MaxMine that will be able to convert a public IP address to the respective geolocation, which means I will know that the IP address of a.b.c.d until a.b.c.f is within the range of ISP something within Indonesia. So that's how we conclude that these machines are actually hosted in Indonesia. Did I answer your question?
Yes.
Okay. Any other questions?
It seems so.
Okay, I'll proceed. So as I was saying, so before we go further, I think we should actually explain the logic behind how IoT devices can be infected. So the attacker on the left here is let's say it's already the very first machine that's already infected. It is probing the internet for these particular ports 23, 23, 23. So these are the two ports that Mirai was looking. But obviously you can look for other ports as well, like SSH ports if you can. But a lot of devices, let's say you have deployed a CCTV at your home network, usually you have an intermediate router. Now this router would have a public IP or an IP assigned by the ISP. But the IoT device usually have a private IP. And everyone knows that private IP addresses are not routable over the internet. So the only possibility of an IoT device can be infected by Mirai is if you have performed some kind of port forwarding on the router. Port forwarding means the router knows whenever it receives packets to a certain port, it will be redirected to this IoT device on a different port, for example. Essentially what happens is that even though you're behind a router, you could be reached directly. And that is how Mirai is able to actually probe and identify machines that are available for exploitation, so to say. Okay. Now, after being able to get a reply knowing that a node is actually online, for example, by sending a ping or by sending a telnet message, you know that the machine is online, you can now start performing brute force by trying to guess the different combinations of username and passwords for the device. Okay, so how Mirai exactly work in the scanning phase? So let's look at this part here. If you look into the source code, we will look into it later as well. So for now, just listen. So in Mirai, it has default username and passwords that are specified here. Can you see here? Username root and password something else. So these are already obfuscated here. So within the source code, it has been obfuscated so that if anyone is actually going to look into the binary or even the source code of the bot, you will not be able to guess that it is actually root. So it's some kind of an encryption. We will go into this in a short while. And to make things more interesting, Mirai implements its own library to perform telnet connection state machines. How many of you are aware of what is state machine? State machine transitions, finite state machines. Okay, so pretty much in the domain of computer science or mathematics, we know that there are a few steps that can take place, and these are usually modeled for network communications. And there are a lot of libraries that are out there for different protocols. For example, for SSH, for TCP, you have different state machines, even for telnet. But interesting for Mirai, instead of using existing third-party libraries, it has implemented by itself. Makes more sense. If you are reusing libraries of known third parties, then you are opening up the chances of you being detected by just looking at which library you're using and stuff like that. So for Mirai, it uses its own state machine. And it also has I wouldn't call it smart, but there is a reason that Mirai avoids scanning the following subnets. So these are subnets, well, for loopback, invalid, internal networks, it's clear. You don't want to try to probe nodes within your own network, but it is also avoiding scanning nodes within the GE company, the Hewlett Packard company, US Postal Service, and so on. For some reasons, they are avoiding it, which means within the logic of Mirai, instead of scanning randomly, every time you want to scan, it makes sure that it is not accidentally scanning any one of these subnets. So it's like a whitelisting. If the IP addresses that it is planning to scan next doesn't belong in this list, then it will start scanning. Okay. Any questions so far on this page? Okay, so I'll move forward. So now we have scanned, we know that a node is actually available. Once the node is available, we will now report to our loader, stating that a potential device was found, and you can start connecting to the device. So that is what's happening here, which is using the function called report working. So what's happening here on the left is showing the file directory. So it's under the folder tools, under scanlisten.go, you will see these functions. So you have these slides, you can have a look with the code alongside later or even after this. Now, once this information is there, the Go-based server will start handling the report and send the credentials or the successful credentials to the loader to make a connection to the IoT device that you just discovered. The third step is to load, which is first to get the credentials that has been sent by the initial scanner. And after that, it will the information, the credentials of the next target or the potential target will be sent into a queue using a standard input process. And afterwards, a server-side application will be executed by the loader. So if you don't understand this part, it's okay. It's not critical, but for those who are slightly more advanced, you can actually follow this this part of the discussion. And finally, once that's done, within the infected device or within the device that the loader was able to access through Telnet, it will try to check if it has wget or TFTP tools that I mentioned earlier, failing which it will upload a 4K binary using a simple echo command. This is where I showed you in the very big animation slide earlier. And once this is done, or if you have wget and tools like that, it will start downloading the binary that is necessary for Mirai. Now, the binary that is necessary for Mirai has multiple different architectures. So they actually plan for different kind of architecture. You have ARM, ARM7, MIPS, SPC, you have different architectures. So they actually plan to infect as many types of devices as possible. So the codes are ones, but the binaries have been compiled for different architectures so that whenever a potential infection happens, this binary that is specific to the architecture can be executed and loaded into the memory. Sorry, any questions from that? Okay. I mean, we can come back to the questions if there are any as well. Is there any?
The question.
Yeah, please.
So thank you. I'm interested in step 3 and step 4.
Okay.
Yes. Is there any specific reason why do they implement the loader in C, but the server is in Go? But why don't they just implement the loader in Go?
Okay, so the IoT devices that we have seen, I mean, a lot of IoT devices right now are really not recent IoT device, but these are all traditional IoT devices that are running on bare-bone Linux that are actually lightweight and stuff like that, just for the basic implementation. So going for a decision with only C-based coding would be easier to be deployed on multiple machines. But the decision of Go, in my opinion, is just a decision. You could have written the server side on C as well. It doesn't matter. But it was critical to have the client side to be implemented on C so that you can really infect and operate on more devices. So a lot of IoT devices would technically be running some stripped down versions of Unix, Linux, and so on.
So I would like to make it clear that step 3 and step 4 happens in the CNC server or in the device itself?
No. Wait. Here.
Step 3 and 4.
So this is step 3, right? So this is a scanner. So this is let's say a previous IoT device that have scanned another device, and this scanner will then send it to the loader. So this is step 3. Step 3 is a different machine altogether. This is not an IoT machine. Okay, but from step 3 to step 4, it will be executed in the IoT device. the checking of wget at TFTP are done within the IoT device.
Thank you.
All right. Any other questions so far? Okay. So we've done this. Okay, we spoke about the download. Okay, the next thing. Once the respective Mirai for the respective architecture have been deployed, now the device will be listening for incoming connection from a CNC. So this device will just wait, and the CNC, which is controlled by the bot master, will issue commands that are listed here. So there are a lot of commands that you can be executed. For example, here, this is perform an application level layer HTTP flood attack on a user. So the CNC will specify, okay, please bombard HTTP requests on IP A.B.C.D, and this IoT device will continuously send the respective traffic. Now, even though these IoT devices are very low in resource in terms of computation power, but remember they are like CCTV devices, which means oftentimes they provide HD capabilities of video streaming. Hence, it would have high bandwidth. So there are a lot of bandwidth that can be used or amplified by these IoT devices to be launched on a potential target. And that's why initially when I say there's the 683 gigabits per second attack traffic that has been observed and so on. In fact, I think GitHub received 1.3 terabits per second the following year or something. But I'm not really sure whether it was Mirai or a variant of Mirai. Okay, any questions? No.
So you said that this Mirai attack is focusing on IoT devices, right?
Yes.
What kind of IoT devices? I mean, you know, right now we have many kind of IoT devices, and one that recently emerged is sensors and actuators with LPWA, low power wide area network, like their communication mode is using like Sigfox or LoRaWAN or Wireshark. That kind of IoT can be attacked by Mirai?
Okay, so the question was, can these specific sensors actuators that are running on low power networks and stuff like that be a potential candidate to be infected by Mirai? That was the question, right?
Yes, yes.
Okay, so Mirai was targeting specifically webcams, CCTVs, and so on. I will explain in the next slides how or why they decided to do that. But to cut things short, if you're using LoRaWAN and stuff like that, but as long as you have the capability of reaching them over the internet, they could be susceptible for attacks that are similar to Mirai, but Mirai is not targeting them. Because the way Mirai works is that, so a lot of botnets will perform some kind of vulnerabilities exploitation, which means there's something unpatched, therefore they exploit and so on. Mirai is actually a very simple bot which makes use of default username and password. So you have telnet capabilities on the IoT device, which is meant for administrators to log in to configure certain things. But since the username and password is known to Mirai, Mirai can also log in and do other things. But instead of doing other things, it's loading another binary that is being used to launch attack. That's the only thing. So if all your actuators do not have the capabilities of remote login and stuff like that, you don't have to worry about Mirai-like attack. Is that clear?
Okay, clear. Second question.
Yep.
Is there any other use than for the DDoS attack? Can be this kind of Mirai can be used for the spying or maybe another more difficult task
Okay.
except DDoS. Thank you.
Okay, so DDoS attack was really straightforward for Mirai because that's traffic that you can generate as you wish. But if you ask about spying, I can speculate because I don't have the facts for this. If you are able to access a certain CCTV, depending on what kind of privilege that you have after accessing that CCTV, you could potentially tap on the stream of the CCTV. So in that case, technically you could look into what the CCTV is doing, or rather what the CCTV is actually viewing. So let's give a different example. So have you heard about baby cameras? Okay, so we have baby cameras that are connected over the internet because you are working and then you want to keep track of your kids at home or making sure that your mates are taking care of the kids and stuff like that. If the username and password for this baby camera is leaked somehow to me, I could technically log in and have a look at what's happening inside your house. So that thing is definitely possible with Mirai. But other than that, I don't think so. You can do credential theft and things like that. But this will be a first step. If remember the case of port forwarding and so on, if I have the capability of SSH into telnet into your device, I could potentially start scanning devices within your home network and see what else I can do. But Mirai is not doing that. That's it. Okay. Any other questions so far? No questions? Okay. So next, so I did mention a lot of things about how Mirai works, but there are a few other things that I'm not going to go into detail, but I will just summarize. Mirai is smart enough to ensure that there's only one instance of Mirai running. So remember how Mirai is actually scanning other devices and trying to log in and stuff like that. There is a possibility that an already infected Mirai device can be scanned by another device and for an attempt to reinfect this device. But Mirai tries to make sure it's efficient so that if Mirai is already installed, another installation will not happen. So they are checking whether Mirai is running and stuff like that. It also kills other processes that are going to be harmful for Mirai. It hides the process name. It doesn't use the name Mirai. When you check the processes that are running, it uses a random name. And if it has detected some competing bots within the IoT device, it also kills the opponent process, which means it wants to have exclusive access on the IoT device. It doesn't want any other people to share. And it also uses an anti-debug technique by registering to SIGTRAP to ensure that if someone is trying to reverse engineer it, then it won't behave normal. So these are all more for reverse engineering. So these are just miscellaneous stuffs for Mirai. So any questions before we start going into slightly hands-on? Okay, if there's no question, let's move on next. Have everyone downloaded the stuffs from the link that I have given?
I have a question.
Sorry, yes.
So, is there any incident that uh, they brute force the Raspberry Pi stuff?
Mm-hmm.
Because Raspberry Pi stuff, they have default and username.
Yes, I mean the
password, like default
yes.
password. But I don't know whether they hard coding in the source code, but is there an incident that they brute force the, because Raspberry Pi also can attach the camera, right?
Yes.
Oh, yes.
So to answer the question, so can Mirai affect other kind of devices besides webcam and so on? The idea that Mirai used, which is I'm going to use default username and password to infect other device, can definitely be extended. You can write a program right now or look into the source code of Mirai, change it so that it starts probing for Raspberry Pi instead of IoT devices, because the IoT devices that Mirai was targeting were all having telnet service turned on. And if I'm not mistaken, Telnet is not turned on by default for Raspberry Pi, but a lot of devices will tend to open up their SSH port. But even if you have SSH port and you don't change your default username and password, I can try to probe and then log in. So essentially, yes, if you do not change the default username password for Raspberry Pis, and the Raspberry Pis either have port forwarding or has public IP address, they can be infected or they can be exploited. Does that answer your question?
There's no incident so far.
Well, wouldn't know because I don't think so. There are more because that behavior is not really Raspberry Pi specific. I could even have a lot of turnkey solutions that are having default username and passwords. I can still probe and infect them at the same way. So it is just reported as a brute force attempt, a malware that brute forces SSH. That's it. We won't be able to link it to just Raspberry Pis. Does that satisfy you?
Yeah.
Okay. Any other questions? And? Is there a question?
No, not yet.
Okay. So moving forward, I hope everyone have downloaded the file, the link that I have given earlier, because we are trying to look into certain things right now. The first thing we want to look at is the Mirai's brute force module. So Mirai has this module that that has this default username and password. We will try to figure out how this works right now. I would like to invite you guys to refer to this link. Just click on it. It's the particular line within the Mirai source code. You should be able to see what I'm saying here. Okay. I hope everyone is able to see the same view. Right? Okay. So pardon me, but since I'm doing it remotely, please help around your friends at the site if some of them are not able to get it. Okay, so this is the Mirai source code link that I've given to you. And this is the line 124 until 185 are the default username and passwords that Mirai have already hard-coded in its codes. So we will go into what gibberish value is this, but essentially this is what it means. The username is root, the password is XC3511, for example. Wait, let me zoom. Okay. I hope this is clear on the screen. So these are the username and password. Now look at the passwords. You have yuan tag, you have password 66666. So these are username and passwords that the author of Mirai have done by looking into the user manuals of the different webcams available. A lot of user manuals are available online. What you just have to do is download this PDF, look into what is the default username and password, and add one entry into the source code of Mirai. This is pretty much what he has done. Password root are very common thingy. Password admin, password. These are also common. You have root without password, that is also common. So these kind of things are all known to a lot of things, to a lot of people. Okay. So any questions about how they came up with this username and password as hard-coded entries? Anyone? Okay, so I assume it's clear, yeah? Okay, so these are the username and passwords that are hard-coded. Now, root is represented as this. These are hexadecimal values in the source code, but this doesn't tell us that X50 is R. We don't know that 4D is O, and so on. So obviously the source code is somehow encrypted, okay? So the encryption, if you notice that every time there is root, it's the same thing. It's the same encryption ciphertext that you get for the same password, for the same clear text. Now we are trying to find out how this happens. So I told you that line 124 to 185 are hard-coded username passwords. Now, if you go in depth into the source code as well as the binary, you would then realize that they are using this magic key called Deadleaf. It's called Deadleaf is because that's one of the few words that you can write in hexadecimal. Hexadecimal is 0 to 9, A to F. So every character can only be the numbers 0 to 9, A to F. So that's why you can write Deadleaf. You cannot write something that has G, H, I, and so on. So they have decided to choose Deadleaf as their XOR encryption. So if you perform XOR, so this is an XOR operation, DE, XOR, AD, and so on, you will get the value, hexadecimal value of 22. So this is the value that has been used to encrypt the text that you have seen on the source code. Any questions for this? I'm not going to go into details how XOR encryption works and so on, because that's something you can read after this, but just know that this is one technique that they use. It's a very fast way for them as well. Now, let's try to actually decrypt what we have seen here using some other online tools. So step one, just click before that. Anyone who doesn't have my slides right now? Because I'm assuming all of you have my slides and it's easier for you to just click on it.
We have it.
Yes.
Okay, okay, great. So just click on step one. So another slide will, another tab will be opened. So this is going to perform an XOR. So what we want to do is we want to select type to hexadecimal and type the key 22. So here, change to hexadecimal, key 22. And then on the left box, type the following code, which you can also get it from here. The very first one. Let's take this as an example. Just paste here, but without the /x. So pretty much just press decrypt and you will get some text that are decrypted here. Are you guys all getting 726F6F74?
Too many connection from this room, I guess.
Sorry?
Too many connection because we are from the same network accessing to that website. So the website responded with the too many connection for you, man. With a little.
Okay, then in that case, you will just have to trust me that this is how it works. For those who can access, good.
Sure.
And let's proceed. So I will just copy this value 726F6F74, and then I would like. So this is what I did. So I've already copied this value. Now I'm going to open another solution that is going to. Well, let me just explain this. So I put in the encrypted text that we have seen in the source code. And since I know that the key to decrypt that is 22, this is the decrypted value, but it still doesn't make sense to me because it's in hexadecimal. I want to change it into something that I can read, which we call the XE representation. So this link will provide the capabilities to convert my hex values to XE. So this is hex to XE text converter. So I will paste my value here. And if I press convert, I will now see the word root. Now the word root is what's here. Okay. So you can now know that this represents root all the time. Every time there is root, this is what you will see. This is what you will see. So this is the encryption that it uses. If you repeat the whole process with this, then you will see this value coming out.
How do you know that the key is Deadleaf?
Okay, That is actually within the, you will have to do reverse engineering to find this out. So what I'm doing right now is, sorry, was there another question or no, right? So Deadleaf was something that was already reported by someone else, another researcher. So I'm just reporting it right to you. But if you go through the process of debugging and reverse engineering, you will realize this, that, okay, this is the key that they're using to decrypt. So we can now look into the decryption process by ourselves. But for the purpose of why I'm telling you guys right now is because now that you have seen how to decrypt, you can reverse the process with 22 to encrypt. So if you are curious, yes, you can add new entries to the source code and build it as your own variant of Mirai bot. For example, if you have some IoT devices that are specific to the Indonesian market, all right, and then you have, sorry?
They are here having some ideas.
Okay, but again, these are all for knowledge purpose. If you decide to do this, it has nothing to do with me. So proceed with caution.
NDA.
Yes. So that's the idea. So now you can actually stress test your own network. For example, if for whatever organization you have to assign devices that are going to have default, or let's say the administrator have configured a default username and password, and the SOP states that you will have to change to a different password as soon as you get this device. And then you assume that they have changed, but then you can stress test your own network using this kind of codes and see how many of these devices did not change the username and password, for example. That's one way how you can use this whole code for a good purpose. Okay? Any other questions on this?
What is the meaning of after that root and password? Yeah.
Sorry, where? Here?
Please look back at the source code.
Yeah, I'm looking at it now.
There is a number 10 there. And then below that 9, 8.
I think this is the priority. You can actually specify which ones should be tested first and the sequence of it afterwards. Because if you know that you're targeting a specific kind of device, you don't want these old passwords to be prioritized. So you can prioritize the very first one. Because how Mirai works is that it won't test everything. The moment that the moment one of these password combination works, it will stop brute forcing any the next ones. Did I answer you? You're talking about this value 10, right? Yeah, that's the priority value.
Where can we find C2 server in the source code?
There's this component. Wait. Let me just show on the codes itself. So if you go to Mirai, so you have CNC. This is the C2 component. So you have many things here. So there's a lot of online resources where you can see Mirai in depth, but I cannot go too in depth today because of time constraints. So I'm just summarizing things so that you know where to look at when you need it. Is that okay?
Yep.
Okay. Any other questions before we proceed with the next one?
Yes.
Is there a question?
No.
Okay. So next, wait, did you guys do any hands-on with Wireshark today?
Yes.
Okay, so we might reuse it now. We have provided PCAPs, network traffic of Mirai operating on a network. So these are all open source data sets. I've also given the links at the end of my slides. but I've already summarized those important files within the downloaded zip file. So if you unzip it, you will see these files there. So first open this file in Wireshark. I need to so open Mirai host brute force 1. Can you guys see my Wireshark view?
No.
No? Hold on. Okay, now?
Yes.
Okay, so you open the host brute force 1 PCAP. And then at the display here, you press telnet. You type telnet. It's case sensitive, so write everything in small caps, small letters, and then press enter. So you should be able to see just telnet based data that are filtered here. Then go for the very first line here. By the way, the instructions of how to follow and what to do is already here on my slide. So you can follow that as well if you can't follow what I'm trying to show on the screen. Okay. So right click. So right click on the first record here, click follow, and then TCP stream. Then you wait for a while, then you can actually see multiple streams that are listed. Here, this is a banner of a telnet server. So this is something very common for all telnet services that are running. You will have a default banner that displays. So when you connect to it, you will see a banner that's being displayed that will ask for your username, and then you will have to specify your password, and it will check whether the username and password is correct and not. And now what we want to do is we want to advance to stream 237. So there's this option stream here. So keep clicking it until you see 237, which will then show you the first combination of username and password that we have seen in the source code file. Could you guys see that? Are you able to see my this window? Okay. So here with the IO error 32, it says that the combination of root and this password is wrong. So if you keep on moving forward, you will see the next combination that has been tried. And then third, admin doesn't work, but root worked. Okay. So when the malware was trying to actually brute force a particular device in the network, the password root was successful. But what else this particular exercise that we are doing is telling us that using telnet, username and passwords are actually transmitted in clear text. So that's why people do not use telnet anymore, even within your own network. So if you have any telnet services running on your network, you have to find a way to shut them down and probably use SSH if possible. This is something that we have to take back from our exercise here today. Any questions for now on this part?
Okay, thank you. Do you think that CCTV or IP camera provider now is already know the information about the Mirai port, and then they shut down the telnet services and change to H, or just only through HTTPS? Do you think the vendor already changed the method for authentication for user?
Okay, thank you for the question. So the question is more like, with the presence of Mirai, are the vendors taking proactive measures to offer more secure remote management connection? This is the question, right? Okay, so this is pretty much depending on the IoT devices itself. You're right. But I think nowadays vendors are giving options on how you want to access the device. You should be able to specify whether you want Telnet, SSH, or web-based, HTTPS-based connection. And that should be configurable. But in most cases, you have everything turned on by default, or either one is turned on by default. But as a user or as an administrator, you will need to know to a certain extent which one you do not want to maintain. It's as simple as how for our wireless access points, we shouldn't use which kind of WEP, WPA kind of a thing. So these are things that are available, but we should avoid those that are weak to cracking and stuff like that. Okay. Any other questions? No? Okay. If no questions, then I will go back to our slide. Okay. Okay, so this is what we did for brute force module 2 on figuring out how telnet traffic can be sniffed using Wireshark to look for the username and password. Have you guys did this just now in the training? Was this already done for the Wireshark? Yes. Yes, okay. Okay, next, we want to look at the, sorry, was there a question? Okay. Next, we would like to look at the SYN flood attack that is within the DOS SYN flooding -2-December PCAP file in Wireshark. Let me change again. DOS SYN flooding. I will clear this. Okay, this is what we should see. Wait, before that, I need to show something. Okay, how many of you who do not know what is SYN flood attack? Do I need to explain what is SYN flood attack? No. Okay, so I will skip this part, yeah? Okay. So go back to Wireshark. Okay. So now you will need to specify in our display the following filter command: TCP flags SYN equals 1 and TCP flags acknowledge equals 0. So when you run this, pretty much you're looking at the very first part of the TCP three-way handshake. This is where a client will send a request, will send a SYN packet to the server stating that I would like to connect to you, and then the server will send a response accordingly. Okay, so did you realize that here, let's say from 25 2.65 onwards to 2630 and so on, the amount of SYN packets that are being sent are having very small variance in time. And the source is actually random to a certain extent. So it has a pattern whereby the source is all having the first prefix 222, but the remaining source IP addresses are randomized. These are randomized, but the times are very short in between. Okay, so in order to look into this in more in-depth, you could use statistics and IO graph. You would be able to see a peak of SYN packets that are being sent here. So these are those that I have filtered. So these ones. There is a peak from around 12 until 31. So you can verify this. 12 until 31. Yeah. You have a burst of these packets. All right. This is the behavior of a SYN flood attack. So in other words, this is one or multiple bots that are spoofing random source IP addresses, targeting a web server. So is it web server? No, it's not a web server. It's port 554, and it is sending as many SYN packets as possible. So what happens when the resulting server has been receiving too many SYN packets? So pretty much it won't be able to accept new SYN packets from legitimate requests. And that is where you start seeing that a website is down and stuff like that. It is simply because the resources of the server has been locked for the purpose of this bogus request. Because how TCP works is that for every one of these requests, a socket will be turned on and it will listen until the timeout. If the process of receiving the timeout and the amount of incoming requests are too high, you will experience a denial of service. So this is pretty much how denial of service attacks are carried out using SYN packets. And if I change my screen back to So here's the spike that we have seen just now. So you can actually have a look. So a lot of times when you have, when you suspect something is wrong in your network, you could use Wireshark to a certain extent to verify the behavior of what is happening in your network. The next example that I would recommend you guys to also try would be for Mirai UDP flooding 1st December. Mirai UDP flooding 1st December. So it's quite big. This file is quite big, so it might take some time depending on your PC in terms of loading it. So for this, we already know that this is the destination IP that we are interested to filter. So I'm going to go for ip.destination equals so ip.tst equals 210.89.164.90. So once you're able to filter that, you will start seeing a bunch of UDP packets that are being sent. The interesting thing about this traffic is that it is not too big. 32 bytes is not too big, but there's quite a lot if you look at into the time. So you can do the same thing like what we did just now, which is statistics. You can go into IO graph. Right. Well, it's okay. Try statistics and capture. Statistics, you have to wait for it to load. And then capture file properties. If you go here, then you will see the average packets per second is 5,191. And this is not normal. This is a lot of traffic per second. So this is behaviors of UDP traffic that are being generated to overload a particular service of a server in your machine. Sorry, was there a question? Any questions so far? Yes.
Thank you. So if we see the Wireshark picture file for SYN flood attack, the SYN flood attack destination port is 554. Am I right?
Yeah. Yeah.
Is there any specific reason, or just they just try to scan any available port and just do the?
No.
Is there any specific reason?
You're asking for SYN flooding attack, right?
Including attack, right? The destination port was 554. Is there any specific reason?
Wait, let me quickly check that. No, I don't think so. That one is actually a particular. Wait, let me just verify this. There should be another file within the folder that you guys downloaded called description, dataset description, right? Because the DOS SYN flooding doesn't have the, how do I say? The prefix of Mirai. So I don't think so that one actually belongs to Mirai. Let me just double check. Yeah, that part doesn't belong to Mirai. It's just another example of data set that we have gathered from the set of open data sets. But for the SYN flooding, it was not Mirai. So the question of why that particular port, it's from a different malware, but it's not Mirai. Is that okay? Any other questions?
I think some of us cannot show the IO graph result as you display on your slide.
For this or?
Even for the previous one. Is that because of the version of the Wireshark or what?
Wait, let me check. Can you please check on the the filters that you have enabled down here. So you have to enable the ones that is saying, if you're talking about the SYN flag, you have to click the one with TCP flag SYN equals 1. Because Wireshark actually keeps track of your historical queries, and therefore you should be able to pick which one you want to actually visualize. So if you actually pick the one which has TCP flags.syn equals 1 and blah, 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 you should be able to see this for the DOS SYN flooding. Does that resolve the issue?
Yeah, so, but there's another question.
I have a question.
Yeah.
This sync flooding, this similar like DHCP flooding or MAC address flooding, like the words or the effect.
Okay, so maybe let me just quickly go to the slides that I did not show, or I omitted just now. Right. So for SYN flooding, so this is how a normal TCP handshake is supposed to take place, normal one. So there is a client that wants to talk to a server, it will send a SYN message. When the server receives that, the server knows that, okay, this guy wants to talk to me. So this is on the last slide, slide 31. So he knows that I would like to talk to the server. The server will say, okay, this was the SYN that you sent. I'm acknowledging that. You can now, if you receive this, you can start sending whatever communication. So after sending the acknowledgement, the traffic will flow. That's the normal behavior. But with the SYN flooding attack, what happens is that you have an attacker, the green guy, he will send a lot of this SYN message, but he will never send you any acknowledgement. When he doesn't do that, the server is thinking that, okay, maybe 100 connections are ready to make, and I'm waiting for the acknowledgement. The waiting period of the acknowledgement is the question mark and the clock symbol here. In that process, it is still waiting. If let's say you or a regular user wants to now connect to the server in that process by sending a SYN, the server will reject your SYN by not sending a SYN ACK because it is already waiting for other people to send an acknowledgement. The basic resources that it has is depleted. That is where you have the denial of service attack. Is this graphic clear to explain how the SYN attack actually works?
Yeah, it's clear.
Okay. Any other questions? No more? Okay. We did the UDP thingy. Okay, the other one is, okay, try to do the follow UDP stream option. Right click on the first row and click follow UDP stream for the Mirai UDP flooding. You should be able to see something like this. Right? When you see things like this, you know something is really wrong. Someone is actually sending you payloads that doesn't make sense simply to bombard your services, basically. Okay. I think that's straightforward, right? So I think we are slowly running out of time. So I will start wrapping up. So let's have a look at the basic defenses against Mirai. So today, while we were looking through the source code of Mirai as well as the PCAP files, the telnet, TCP streams, and so on, we have noticed that best practices like using default passwords and limiting remote access was not done. So when you want to deploy malware, when you want to actually protect yourself from malware like Mirai, one of the most important thing is to ensure best practices are followed, which means you cannot use default passwords. You have to change it. I think yesterday, Mr. Matthias also spoke about the usage of different passwords or changing passwords, having complex passwords. to prevent brute forcing and so on. Yes, these are things that we need to take into consideration. But remember, it is also not good if you have a single long complicated password that is used for multiple years, because you might actually use this password on a particular service on the internet, and the moment the password has been leaked, people will now have more information, or rather they will now know, okay, this is a potential password that they can use. So if they ever see your username and password, username somewhere else, they will try to use this password. So another best practice is to regularly change your complex password. Okay, next. If the device allows automatic updates, you should enable it, especially security updates. Otherwise, as network administrators or users, you must proactively apply patches or updates to ensure that your system is always protected from cyber threats or botnet threats, for example. And there's also the necessary needs of having out-of-band notification. So in the very first question that I received today was, how do we know that a particular malware infection is belonging to an Indonesian cyberspace or not? Can I know if there's anyone from ISP here? Do we have any representatives from ISPs? We do? Okay. So usually, if I'm not mistaken, there are organizations like the Shadow Server Foundation that proactively sends information about which IP addresses are known to be infected with which malware. Can I know if your ISP is actually receiving that? Or actually, even the administration of the universities, for example, Brawijaya, they should be able to receive this information. So what you need to do is that you have to go to the Shadow Server Foundation's website, and then you will just have to say that this is the range that belongs to me. They will check, of course. And once it's verified, they will start sending you daily or weekly feed telling you which of the IPs in your network that are known to be infected by malware. So even if you don't detect by yourself, feeds from Shadow Server Foundation could actually help you to investigate further. I mean, if you want to talk more about this, you can contact me directly. I can link you up with the necessary person. So these are all out of band notification so that you get to know what needs to be done next and so on. And finally, you should also have an alerting mechanism within your organization for end of life or EOL devices. A lot of EOL devices also means that you don't have any updates anymore. Security updates, it won't be supported. So you need to also keep track of this. So usually you have asset management systems that also keeps track of EOL devices in your network. Anyway, to conclude, so everyone, which includes the end users and administrators, should keep themselves updated of latest security trends, and read blogs that are security related, or minimally get involved in the security networking events like this. Keep in touch with other people, with me, for example, keep discussing on what's happening, how can I improve certain things and so on. And always follow and apply security best practices. And remember, no matter how good you are in terms of your infrastructure, securing everything, human is the weakest link in securing our cyberspace. And with this, I think this would be a great link to the next panel session that also speaks about security awareness in addressing malware threats. Thank you, and I'm open for questions if you have any.
Thank you very much. Enlightening presentations. I invite question. Okay, one more question.
Okay, thank you. Did you even know about application name is chain enable?
Sorry?
Did you have heard about application chain enable?
I can't actually figure out what application is that. So
Okay.
probably not.
Maybe about 7 or 8 years ago, I'm using this application tools, chain enable, chain enable.
Okay, okay.
Chain enable. So at that years, I'm harvesting the username and password from my users.
Okay.
So they are using telnet connection, and then they using application using HTTP. They log into their username and password. So using VoIP activity, and I can see the transaction of voice application on their side. So I'm trying. By now, this application is no longer support in Windows 10. So I'm asking about, is there any application like similar like chain enable? It's very dangerous if this application used by people spoofing the network and then they harvesting the username and password. It is very dangerous for us. Do you think by now other applications such chain enable on the internet? Do you think?
I'm pretty sure we have something similar to that, but like what you said, you need to be within the network, which also means in most cases you need to have a port mirroring of all the network traffic into a single port to see everyone. Otherwise, it will only work if you have a hub kind of a network device, so to say. So if you're asking from a perspective of a user, yes, it's fun to do it, but from a perspective of administrator, sometimes you want to do that. So you can drop me an email after this. I will pretty much find out, because I've heard about this, I can find out what is the recent tool that is working. Maybe it's not working on Windows, but it's working on Linux. You can use it, but you will pretty much have to use port mirroring of your traffic to look at it. But from an administrator's perspective, there's two things you need to figure out. First, whether the university policy or the organization policy allows that to take place. Sometimes you want to do that because you want to raise awareness, tell people that, hey, you're not using blah, 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 that is secure and stuff like that. And secondly, the question of what happens after you collect them. So that's another question that someone needs to answer before you go into this direction.
Okay, thank you.
Any other question? No other? Okay then, let's give big applause to. Let's give big applause to our guest.
Okay. Terima kasih and see you guys soon.
Yeah.
Bye.
Bye.
Thank you.
Right. So the next session will be forum dialogues for